Hey there folks, Mr. G here with another educational video. This time we're going to be talking a little bit about our new unit, which starts off by talking about squares and square roots. Now, as you might have guessed, if we're talking about squares and square roots, we're going to be talking about the shape to start off with. And the first thing we're going to consider is how do we make squares when we have a bunch of objects like this? So imagine we have a bunch of little donut rings here. Let's say I want to arrange these and make them into a square. Now the key is that a square has the same length on all of its sides. So what's the smallest square I can make? Well, it would just be with one piece. Because notice, this has a width of 1 and a height of 1, so it's the same on all sides. So this would be our smallest square. The next square I could do is 2 on all sides. So that would be 2, that would be 2, and I would have a total of 4 circles. And we get 4 circles from 2 times 2, 2 wide and 2 tall. The same thing would be true for this one, right? Here we have 1 circle, which is the same as 1 times 1. What would our next one be? Well, it would be 3 wide, 3 tall. It would look a little bit like this. Here we would have 9 circles, 3 tall, 3 wide. Now, what would you predict would be the next square we could make? Well, our next square would be 4 by 4. And how many circles would it take there? Well, based on our pattern, we would expect there to be 4 times 4 circles, which would be 16. And we could continue this on and on and on. These numbers of circles that we get, 1 circle, 4 circles, 9 circles, 16 circles, and on, these are called perfect square numbers. And how do we get our perfect square numbers? Well, they're just the numbers in order, but then we multiply it by itself. So we get 1 from 1 times 1. We get 4 from 2 times 2. We get 9 from 3 times 3, 16, 4 times 4. And we could continue this pattern on and we could get all of our perfect square numbers. When we're talking about perfect squares, there's also a shorter way that we can write it. When we have something times itself, one way that we can write this in mathematics is we write 1 with a little 2 up top. So that means that we do 1 times itself. For 2, we do 2 with a little 2 up top, 3 like this. And the way we say this when we have a 4 with a little 2 up top is we say 4 squared. Basically what we're saying is it's the number of objects inside a square where each side is length 4. So our 4 squared, area with the square of a square with a side length of 4. And that's true for all of our perfect squares. The area of this square, 1 tall, 1 wide, would be equal to 1 times 1, base times height. Same thing over here, base times height, 2 times 2. Here, base times height, 3 times 3, and so on and so forth. So the number of circles inside is the same as the area. And so when we square the number, we get the area of a square with the side length of whatever number it is we're squaring. So what would the area of a square be if the side length was 11? Well, based on our pattern here, it should be 11 squared. Or 11 times 11, which if you plug into your calculator, should give you 121. And just to remind you, this 121 is a special number. We call it a perfect square. Just like all of the other perfect squares that we found up here. What if we try and go backwards? What if we try and ask, is 200 a perfect square? Well, so that's like saying, can we make a square where the sides are integer numbers and the area is 200? Well, there's a couple different strategies here. The first one we could do is just try and guess and check. So let's pick a number, well, we know it's going to be bigger than 11 because 11 times 11 was 121 and 200 is bigger than that. Maybe we try 14. So we'll do 14 times 14, which would give us 196. Okay, so that's not going to work. It's a little bit too small. So let's go to the next one. Let's go to 15. So 15 would be 15 times 15, which is equal to 225. Well, that's too big. But now we can see the answer to our question. 14 and 15 give us numbers that are below it and above it. And since there are no numbers between 14 and 15, there are no perfect squares between 196 and 225. So if 200 fits in between these two, it's not going to be a perfect square. But there are some other strategies for checking if a number is a perfect square. Let's do a different number to see what another strategy might be. What about 144? Our other method that we can use is called a factor tree. You've probably done factor trees in the past, but let's do a quick reminder about how they work. We start by writing our number out here, and then we think of any number that we can divide this by. We know it's even, so we can divide it by 2. So we draw 2 branches. On one of them we put the number 2, which is the number we're dividing by, and then we put the other number that we get as a result. So 144 divided by 2, that would give us 72. And then we repeat the process again. For 2 here, there's no other number we can divide this by besides 2 or 1. So we're going to look at our other number here. Again, this is an even number, so I can divide it by 2. And then whatever's left, this would be 36. We got another even number, so let's divide it by 2 again. Divide 36, we'll get 9. Divide by 2 again, and we'll get 18. From here, I know that 18, we can divide it by 9, so I'm going to divide it by 9, which gives us a result of 3. Now, 3 I can't divide anymore, but 9 I can. I can divide that into 3 and 3. And if you do this properly with the factor tree, you should end up with all numbers around here that are called prime numbers. If you remember, prime numbers can't be divided by anything but 1 in itself. Once we have all of these prime numbers here, we circle all the ends of our branches. So we don't circle the numbers in between that eventually split off, we circle all the ends of our branches. And because of the way we did this, we now have a way of writing out 144 as all of these multiplied together. Just realized this should have been a 2, not a 3. Now that we fixed that, in order to find if it's going to be a perfect square, what we need to do is look at all of these factors here, so all of our prime numbers that we got from our factor tree, and see if we can pair them up. So here we've got 2 2s we can pair up here, we've got 2 3s we can pair up, and another set of 2s over here. So if they all pair up like this, then this would be a perfect square. To show that, the way that we show what this perfect square would be is we take one of each pair. So we take one of these 2s, we take one of these 2s, we take one of these 3s. Then we do the same thing with the same pairs again. So we take the other 2 from here, we take the other 2 from here, and we take the other 3 from here. And if we multiply all of these together, 2 times 2 times 3 would give us 12. And same thing over here. 2 times 2 times 3 would give us 12. So if we can pair up all of our factors here, that tells us that we would be able to split them up and make 2 copies of something times itself, which is the definition for a perfect square. The third way we can check if it's a perfect square is to use a calculator. And for that, we would use a square root button. Now, what a square root button means is the opposite of a square. So if we know that 12 squared equals 144, then the square root of 144 is equal to 12. So this little symbol right here almost looks like a check mark with a line over it. That's a square root. So the squares and the square roots are opposite for one another. For this, when we take 12 squared, what we're really doing is saying our side length for the square is 12, and then calculating what is the area. So we're using this squared to find the area. Square roots go in reverse. We start by knowing the area is 144, and we want to know what is the side length. We would take the square root of 124 and get 12. So that would be our side length. This might seem a little bit weird, but let's try using this idea of square roots, going from the area to the side length, in a couple of questions. So what is the side length of a square with an area of 36? This is the same as asking what is the square root of 36? Or what number multiplied by itself is 36? You could use a calculator, you could use guess and check here, but regardless, the answer you should get is 6. So if we were to draw a square with an area of 36, each of the sides would be equal to 6. Base times height is 6 times 6, which is 36. Same question now with 81. So again, we can ask the same question. What number multiplied by itself is 81? What's the square root of 81? And whether you use guess and check or the button on your calculator that looks like this, you should get an answer of 9. So just like above, Our base and our height need to be 9 in order for our area to be equal to 81. 81 is 9 times 9. But what if our area isn't a perfect square? What if our area is something like 200, which, if you remember, we already showed that 200 is not a perfect square. So we know that the numbers aren't going to work out nicely like these two parts. So what two numbers go here? Well, what we can do is, even if this isn't going to be a whole number, we can estimate how big they're going to be. Because if you remember, we know that if we have a square with 14 on each side, it should be equal to an area of 196, which is a little bit smaller than 200. And if we have 15 on each side of our square, our area is 225, which is a little bit bigger. So if 196 is a little bit smaller than 200, which is a little bit smaller than 225, that tells us that these sides in green here should be somewhere between 14 and 15. In other words, the square root of 200 should be somewhere between the square root of 196 and 225. So the square root of 200, the sides of these side lengths, should be somewhere between 14 and 15. Now, using this method, we can't get an exact answer, but we can get something pretty close. Notice 200 is a lot closer to 196 than it is to 225. We could estimate this and say that, well, the square root of 200, the side length for this square, should be closer to 14 than 15, because 200 is closer to 196. So we could make a guess here. Let's say we go to one decimal place. Let's estimate something like 14.2. We can check this now using our calculator by plugging in the square root of 200, which again, this square root tells us what's the side length if our area is 200. If we plug that into our calculator, we're going to get a big long decimal like this. And this is true for any non-perfect square number. You'll always get a big decimal like this. And even though your calculator cuts it off, it actually goes on forever. And as we can see, our estimate is pretty close. 14.1, 14.2, we're pretty close to the right answer, just by estimating using the two perfect squares next to it. Alrighty folks, let's check your understanding. There are 4 questions up here, so grab a piece of paper, try them out for yourself. The 2 at the bottom there are a little bit tricky, but I believe that you can do them. We just talked a lot about fractions. See if you can figure them out. All done? All right, let's go over the answers. For the first one here, we're asked to use prime factorization on 300 to see if it's a perfect square. Now remember, we have to make a factor tree when we're doing prime factorization. So we're going to split 300. Well, I know that 300 we can divide it by 10. It would be 10 and 30. Now 10 I know I can divide up. I could divide that up into 2 and 5. 2 times 5 would give me 10. But 30 I can also divide up 30. I could do that as 3 and 10. And then I can divide up this 10 into 2 and 5. And now all of my numbers here are prime numbers. They can only be divided by 1 and themselves. So let's circle those. Those are my prime numbers. So that tells me that I can write 300 as all of these numbers multiplied together. Now let's see if we can pair them up. Well, we've got 2 2s here, so that's good. Those we can pair up. We've also got 2 5s. We can pair those up. But now we're left with 1 3. There's no pair for it. So since we can't pair up all of our numbers, this is not a perfect square. And we can check that using our calculator as well. If we plug in square root of 300 into our calculator, and there you would use this square root button right here. So that one right next to it there. And for most of them, what you would do is you punch in 300 like this, and then you hit the square root button. And what you'll see is that we don't get a nice number. We get 17.320508. And again, this would go on for much, much longer, but our calculator only has so much space. Again, this is not a whole number, so it's not a perfect square. All right, for this next one, we want to estimate this. We know it's not, or we're told that it's not a perfect square because we're being told to estimate it and then check with our calculator. So in order to estimate it, the method that we use is we find what 2 perfect squares are on either side of it. So looking at 50, well, let's try out some numbers and see if we can figure out where it fits between. So let's start off with 5 squared. 5 times 5 would give us 25. Okay, need to go a little bit bigger. 6 squared would be 6 times 6, which is 36. Okay, we need to go bigger than that. 7 squared is 49. Okay, that's pretty close to 50, but we still need one that's bigger. What about 8 squared? That would give us 64. So now what we can say is that the square root of 50 is going to be between these two numbers here. Since 50 is between 49 and 64, the square root of 50 is going to be between 7 and 8. Now, it's going to be a lot closer to 7 than it is to 8 because 50 is very close to 49, and it's a lot further from 64. So we could estimate that the square root of 50 is maybe something like 7.1. And if we plug it into our calculator, what we get is 7.0710678, which if we rounded to one decimal place here, would also be 7.1. So our estimate's actually pretty much spot on. For our bottom two here, remember, squared means something times itself. So this would be 2 over 5 times 2 over 5 times itself. And we know how to multiply fractions. We multiply the tops, we multiply the bottoms. So this would be equal to 4 over 25. Now what if we wanted to go in reverse? This question is now asking what fraction times itself gives us this. Now to help us out with this question, we're going to look back at our previous one and notice both the top and the bottom here were both perfect squares. And both of these numbers are also perfect squares. And we got this 4 from 2 times 2 in our fraction here, and we got the 25 from 5 times 5. So for this one here, let's notice that 25 is 5 times 5, and 49 is the same as 7 times 7. So what that would tell us is that this top part is 5 times 5, the bottom is 7 times 7. So 25 over 49 is equal to 5 over 7 times 5 over 7. So the square root of 25 over 49, what fraction times itself gives us the inside here? The answer would be 5 over 7. Now the last one's a little bit tricky. Don't worry, you'll get some practice with that sort of stuff. That's the end of our video here. Thanks for tuning in. Make sure that you try out some of the homework problems, and I'll see you all in the next video.